In this video, we will find solutions to first-order difference equations. Difference equations can be defined as equations for sequences that describe how one value in a sequence relates to the previous value. Sequence of numbers y0, y1, y2 up until the yth term is an infinite and ordered list of numbers with one term yt corresponding to each non-negative integer t. We call yt minus 1 the tth term of the sequence, since in our notation the first term is y0. Often a sequence is defined by a formula. For instance, the formula yt equals to t squared generates the sequence in which y0 is going to be 0 because the index t is replaced as the variable t and is squared. y1 becomes 1, y2 is 4, until again the yth term. The sequence 3, 5, 7, 9, and goes on to the infinity may be described by the formula yt equals 2t plus 3, in which the t index must be bigger or equals to 0. Now suppose we have the equation yt equals to yt minus 1 plus 3, in which yt is the variable we're working with and yt minus 1 is the variable previous to it. And we know what does the y0 stand for. We can find what is y1 and y2 equal to using the information we know. So in order to find y1, we need to use y0, since 1 minus 1 is 0. y0 plus 3. And in order to find y2, we need to use y1. So y1 plus 3. And we can replace y1 with the definition of it, which is y0 plus 3 plus 3. We notice that the index and the number of 3's that we have in the formula match. So when we have 1, we have 1 3. When we have 2, we have 2 3's. So we can write the formula yt equals to y0, which is a constant in each, plus 3t. Now we can find what does the yt stand for at any index t. Let's say we know that y0 is 5, and we want to find what does y12 stand for. So we replace y0, which is 5, plus 3 times the index, which is 12, equal to 5 plus 36 equals to 41. So y12 is 41. The equation yt equals to a times yt minus 1 plus b indicates that the index t is bigger or equal to 1, and where a and b are numbers, this is called the first-order linear difference equation with constant coefficients, and the value of y0 is an initial condition. It is said to be first-order because of the equation only involving one other previous term in the sequence. By a solution of a first-order difference equation, we mean an expression for yt as a function of the positive integer t depending on the initial condition of y0. In the cases that b equals to 0, the equation becomes yt equals to a times yt minus 1. This is a homogeneous first-order linear difference equation with the constant coefficients. Using it, we can find what is y1 equal to. So that equals to a times y0, and y2 equals to a times y1, which equals to a times a, which becomes a squared, times y0. You can notice a pattern and therefore we can write the general solution of yt equals to a in power of the index t times y0. For now, the number y with a star is known as the time-independent solution. The general solution to the equation we've seen before, yt equals to a times yt minus 1 plus b, in the cases that only where a does not equal to 1, we can find the general solution using the formula yt equals to y star plus parentheses y0 minus y star times at, a in the power of t. But this is true only in the cases where y star equals to b divided by 1 minus a. Now you can see why a cannot equal to 1, because that means we will have to divide by 0, which is not going to give us a solution. Now let's consider the case where yt equals to 2 yt minus 1 plus 1 with y0 equal to 1. In that case, a equals to 2 and b equals to 1. So we can find what is the y star equal to. Y star equals to b divided by 1 minus a equals to 1 divided by 1 minus 2 equals to 1 divided by minus 1, and that equals to minus 1. So the solution to this is going to be yt equals to minus 1 plus parentheses 1 minus 1, close the parentheses, 2 in power of t. That equals to minus 1 plus 2 times 2t, 2 in the power of t. This is the answer to the general solution of this first order difference equation. Now let's consider a different example in which yt equals to 5 times yt minus 1 plus 6. So a equals to 5 and b equals to 6. We also know that y0 equals to 5 divided by 2. Now we can find the y star, which equals to b divided by 1 minus a, which is 6 divided by 1 minus 5, which equals to negative 6 dividing by 4. The minus was moved, which equals to minus 3 divided by 2 because we divide by 2. Now we can find the general solution of yt, which is yt equals to minus 3 divided by 2 plus parentheses 5 divided by 2 minus, which becomes positive, plus, because we had a negative number of y star, plus 3 divided by 2 times 5 in power of t. Now we add, which is minus 3 divided by 2 plus 8 divided by 2, which just becomes 4, times 5t. And this is the general solution. Here are some practice problems that you can try. In the first part, you have the yt equation, and you can try it for both when y0 equals to 3 and when y0 equals to minus 2, and the same for the one below. And the answers will appear on the right in the next slide. And here are the answers.